I thought it was a really good way to start off in talking about system thinking. Because when I see this photo that I took a few years ago, it shows so much of why we need to think about things as a system. It shows tourism, amenity recreation, infrastructure, ecology, and the weather. And all of those aspects are stuff that is really important when we're trying to talk about the benefits of thinking of the system as a whole. So we're all sort of know about how, we've all traditionally been thinking about things in boxes. System thinking isn't a new concept, but what we're really trying to do is break down those barriers of sort of trying to think things in boxes and separate from each other. What we're really trying to look at is trying to sort of think of the system as all this interconnection. It does mean different things to different people, but it really is that interlinkness between our communities, the nature and our infrastructure, and how we use those to the best of their in the most efficient way possible. And by using something like this map here, we can actually start mapping out how those systems interacts, where the impacts and dependencies are. And it gives that visual representation that's really important to try and understand that. And when we're talking about how we want to solve issues, that having this interconnectedness and understanding, what are those critical assets, how do things impact each other, is really, really important. So it's like the source receptor pathway. We can model the pathway where the source is and have multiple sources and how those pathways hit our receptors. And are they at risk? And do we have to really try and focus on them to make them as the best they can be? And it's understanding those relationships, not just within the infrastructure, but with people, regulation, how our environment interacts, and all those other sort of really, some of those negative things that we really need to take into account. So, but one of the big things is really trying to collaborate. I talked about the boxes a minute ago, but really trying to push those boundaries and understand how these things interact. So this picture showing that, we have this nexus between society, regulation, and market. And I appreciate it's quite similar to the environment, society, economy triangle. But we have societal values are really important. Our customers, our communities are much more savvy and environmentally conscious, along with our shareholders in those cases. And our community is the heart of all what we do. We need to work within, have dialogue around our current and future regulations, and to sort of start thinking about, where we can get acceptance of less conventional solutions and how they can give us quite a lot of benefits going forward. And understanding what the risk appetite is. Where that can be measured and explained accurately is really powerful, and to really understand what the system we're working in. And Amina will be talking a bit about regulation in her segment. And we need to really understand our current and future market. It says delivery there, but it's not just about the delivery. It's how things are opening up. It's how we have, potential energy sort of impacts and all that stuff that's going on in the world right now. And there's a lot of changing rules, which can bring their own problems, but also can open ourselves out into opportunities. And we can try and work together to actually, where are the bounds of possibility for sustainable solutions if we try and push this and collaborate? And in that nexus in the middle is, what is that most beneficial solution? And it's trying to move away from I built this and I didn't need to build anything to we. How can we and collaborate together to get the best solution? Because we're not going to be able to meet net zero and all those other things if we don't work together. And I thought this is quite a nice quote from Transferring Infrastructure Performance Roadmap. It's that the roadmap to 2030 presents a vision for the future where we collectively prioritise the societal outcomes we need and use data technology and improved delivery models to achieve them through our interventions in the built environment. And it's that collective prioritisation. What is the most critical things we need to be doing? It's really important. And I talked a bit there about collaboration. And it's not just about the intervention of the collaborating to make an intervention. It's also about owning it and then tracking and sustaining it as we go forward to really to make sure that we understand, what have we done and how can we learn from it, and sustain it into the future to make sure we get the to inform the next cycle and using that digital analytics to really help us really try and ascertain, well, what information do we need? How can we use that to best our advantage to really try and understand what we've got here? And the part of the issue we have when we're talking about systems and natural systems is that they don't come along the same time frame that our conventional solution has. So it's really trying to understand that and making sure that we all pull together and sort of trying to understand how we can sustain those benefits, even though they might not be as understood or have on the same timeline. And it's collectively, how could we piece all these puzzles together? We all have those different pieces depending on which areas we work in, and how can we then, put all those pieces together and shape them to make them fit. So some of the tools that we've been using within Stantec is the TOTEX hierarchy and other investment decision criteria. So TOTEX hierarchy has been used for a number of years now, but one of the things that we've tried to add in is having that collaborate sort of key and fundamental when we actually do this. And one of the things that when you're applying the TOTEX hierarchy is to be curious. We get given project briefs and we need to satisfy an outcome, but it's really trying to ask those questions at the start. Do we really understand what we need to do? Do we need to build anything to start with? Can we eliminate that? Or if we can't eliminate it, can we operate or invigorate our assets much more effectively? So we might need to, do we need to fabricate at all? And this is not a tick box exercise. It's not about saying one thing over another. It's about how all these different principles can work together to get the best benefits of the solution. And really trying to understand what do we need out of the system and how do we want to function further. And as we're moving forward into PR24, that we have other tools in the metrics. So biodiversity net gain, for example, is becoming a much more prominent feature. And it's really trying to understand, how do we incorporate these other considerations? It's not just about cost, it's about all those 6 capitals and, that human, natural, social aspects of it. And where is that push-pull between those capitals to make sure we get that best balance overall? And carbon accounting is something that is a really useful tool to understand where are we in our sustainable approach. I've been doing carbon accounting for about 15 years, and it's changed massively to being something that we used to worry about where we get our emission factors from, to being really quite fundamental to what we want to do. But where and how we intervene is really, really important, and that time frame. So as the curve is showing, that if we could build nothing, that's obviously the best we can do. But as we move down the curve, the opportunity to save carbon becomes less. But that's not to say that we can't still focus on, if we can't do nothing, to build less. Can we build smarter? Can we build more efficiently? And really trying to understand that and challenge the status quo, challenge of how we've conventionally done this to make everything a lot more beneficial overall. Example of where have done this is we've used the TOTEX, what we call as a blended TOTEX. So we have looked at trying to sort of take those principles and look at sort of opportunities and solutions. But in this, there is inherent risk, and this is why we call it risk mapping as well, is that we have stuff at the green at the top that is maybe a bit more comfortable. And as we move down, so this is like trading with treatment works, looking at technology tipping points and dry with a flow headroom sacrifice. But as we go through, challenging models, looking at more nature-based solutions, which will be talked about later in this webinar, and all these catchment nutrient balancing and things like that, all these elements have inherently more risk, not necessarily that they are more complicated in terms of, say, the technology, but they are a bit more uncertain. There's different risk associated with it. And, that risk appetite needs to be looked at. And we applied this onto a big program of work. It was about 80 schemes, and about half of them we felt there was actually opportunities to challenge those conventional solutions. And we managed to do carbon assessments on all of those schemes and really trying to compare the baseline to these low carbon opportunities. And we found that actually there was about a 60% reduction in cumulative carbon over that time. And comparing that to a successful initiative we did in AMP5, that was showed around 20% saving. And not necessarily all of these things have will come to fruition, but it's showing the opportunity and how carbon can be a really useful tool. And when we carried out this, we didn't just like the sustain track, we didn't just intervene and walk away. We really tried to sort of look at what can we do across what is being done across the programme, but making those risks visible, and created this spreadsheet to really try and emphasise that and look at all different aspects. We have live document monthly check-ins, and it allows that collaborative decision making to happen. And we also coupled that with looking at the delivery of that, so we could adapt if we needed. We found in doing this risk assessment that it was becoming more sort of risky, and the risk output was starting to outweigh the benefits. We could start dialing back and actually saying, well, actually, we need to stop. We need to do this. We need to do a check-in. We need to understand where we need to go, and using that time to our advantage to adapt as necessary. So finally, I've given a few examples there, but system thinking is everything. It's an entity is a system at the end of the day, and is that asking those right questions at the start and being curious? But some examples of what we've been involved in is, London 2100, sort of the living with water, looking at flood resilience, blue-green planning, but also looking at ambitions into the future, and trying to understand, well, how can, if we look at it as a system, mean that we actually get the most beneficial outcome? Thank you.
Perfect. Thank you, Charlotte. That's brilliant. Really interesting. Thank you. And nice to see a summary of all the things that have been done, because it's quite a range. Yeah, brilliant. Thank you. So that leads us on to, Charlotte will be back later on during the Q&A session at the end. But for now, if we can go to our first poll question. So our first poll question is, with the changes to agricultural regulation in the UK, should water companies and other stakeholders be given more tools, opportunities and funding to help incentivise equitable, fair share behaviour of landowners? So we're just wanting a yes or no response to that, please, and we will discuss that with our presenters later on in the webinar. We'll go on to our next talk, that is from Amina.
Thank you. So the Charlotte's presentation and overview to systems thinking is a really good intro to what I'm going to tell you about, which is how we've applied systems thinking into how we do catchment management in United Utilities. And as custodians of the natural environment, with 56,000 hectares of owned land in the Northwest, you have been applying catchment-based approaches on our land to deliver environmental and water quality improvements for many years now. And through our catchment management experiences, starting with, for example, our long-standing Sustainable Catchment Management Programme, or SCAM, and working with many partners over the years, we have developed what we now call our catchment systems thinking. I've been working on it for the last 5-6 years. And for us, CAST is much more than the water that comes out of our customers' taps and is taken away from them, from their homes and businesses. At UU, it is the approach we've taken to managing catchments in a holistic and integrated manner, so that we can understand the impact of our activities on the environment more broadly. And the key elements of our CAST approach include things like considering what's best for the environment and communities, but also integrating and prioritizing risks and how they interact at catchment scale, to integrating and driving multiple benefits and developing better ways of working through place-based governance, collaboration, long-term planning, and working with partnerships with like-minded organizations. We first piloted our CAST approach in the Petteril catchment, which is part of a much larger operational catchment, the Eden in Cumbria. And what we saw there by applying CAST was that our regulatory drivers, which were requiring us to build new phosphorus treatment in very small, very rural wastewater treatment works, but also asking us to address nitrates from a drinking water perspective. These regulatory drivers didn't necessarily align with the bigger issues around nutrient management in the Petteril, or indeed in the Eden, which came from intensive farming activities and diffuse pollution. And it didn't necessarily tackle the flooding issues that the catchment was suffering with, and especially in the aftermath of Storm Desmond. So we worked with the Environment Agency and with catchment stakeholders like the CABA host, the Eden Rivers Trust, to first pilot what became known as Catchment Nutrient Balancing Approach. And this enabled us to offset our requirements, our sort of end-of-pipe permitting requirements, with catchment interventions, which then allowed us to tackle the issues and the risks that we now understood a lot better at catchment scale in a much more integrated way. And what we found by taking this systems approach was actually United Utilities was not the only big business or beneficiary looking to drive more resilience in the catchment in an integrated way. Nestle, for example, were also interested in the resilience of their supply chain in the Petteril, because they've got a number of dairy farmers there that supply to their Nescafé factory in the Eden. And these farmers were struggling due to flooding issues, land management problems, and we worked with them in a much more integrated and collaborative way, not just with them, but with catchment stakeholders and the regulator, to test these new ways of permitting, like catchment nutrient balancing, but also develop hybridized and innovative solutions that were able to allow us to deliver above and beyond our regulatory requirements. And the benefits we see in the Petteril now are beyond our expectations. CAST is truly the gift that keeps on giving in the Petteril, that's what we keep saying. And so far, we've achieved considerable nutrient reductions at catchment scale, where the measures that we were able to offset with end-of-pipe solutions have shown to deliver not just against nutrients, but also an additional £1.7 million of natural capital benefits, mostly by addressing this additional risk around flooding. It's also resulted in considerable value for money for our customers, the capital efficiencies with the less engineered solutions in the order of about £7 million of efficiencies in AMP6 and AMP7, and more expected as we roll out into AMP8. And also through things like match funding from the Eden Rivers Trust and from having Nestle co-investing in the catchment interventions we deliver to deliver 50% of the costs. And this is really an important point when you're coming to catchment nutrient balancing and how to get around things like the polluter pays principle and not really paying for what should be paid from farmers for their fair share reductions. Having non-regulated businesses like Nestle supporting farmers to deliver their regulatory requirements allows us to get around some of these issues. And this project is delivering value beyond assets. It continues to redefine what it means to work in partnership, with partners now working with us to increase the scale of nutrient trading beyond the Petteril into the Eden and beyond United Utilities and Nestle to include more beneficiaries that want to co-invest into the Eden as well. We're now forming a governance type of consortium that's looking to attract multi-million pound investment in the Petteril, of which UU is now one of many other beneficiaries. And beyond the Petteril, we're now cross-pollinating the CAST approach across the Northwest, not just in the rural catchments like the Eden, but also in heavily urbanized ones, such as in the Greater Manchester area, where we're using catchment systems thinking to tackle the water quality issues that we have in the Manchester Ship Canal. And we now know that partnerships are absolutely essential to the successful implementation of things like catchment systems thinking. Whether it's a charity, NGO, a professional organisation, or even a regulatory body, different stakeholders can provide different capabilities and offer different possibilities when it comes to what we can do. And working together means that we can provide a host of new opportunities that help to deliver increased benefits for catchments. And we're tackling some pretty big problems as we move into PR24. The water challenges are not just for now, they're things that we know we're going to have to tackle in the long term. And we can't do this in isolation. Harnessing partnerships means that we can generate multiple benefits and we can build a much more resilient water environment. So a good example of this is the strategic partnership that we currently hold with the Rivers Trust, to which I'm seconded to facilitate a more joined up approach to the Rivers Trust movement and with water companies beyond United Utilities. And we've been working together in the Northwest with the Rivers Trust movement for many years now. But the working together has been very project and delivery based. But we now want to be more focused and more strategic so that we can influence change in a transformational and systemic way. And in order to influence change more effectively, we've now formalized a strategic partnership with the Rivers Trust, which we announced last year. And it's got its own terms of reference with co-designed objectives, a proper governance board, and we've got defined work streams and key deliverables. They're delivering already pretty important projects. And it's all about building a future roadmap for a long-term sustained partnership and collaborative ways of working to deliver a resilient water environment that is driven by better evidence, long-term collaboration, where we see a greater societal involvement and ownership and large-scale investment in sustainable solutions. And through our partnership with the Rivers Trusts, one of the key things we want to be more strategic about is our approach to nature-based solutions. These have got a key role to play in making the water environment and catchments more resilient to current and the future challenges that we face. And they lend themselves really well when it comes to catchment systems thinking and partnership approaches. And in the Petteril and other projects, we've applied many of nature-based solutions as well as hybridized opportunities to combine natural and engineered interventions. Therefore, we want to scale up this approach. We want to standardize it so that we have better asset management plan. We've got more flexibility around the regulatory environment, and we've got a sort of a toolbox with wider sustainable solutions to help us drive a better value for society and the environment, particularly in the context of adaptive planning. With this strategic partnership with Rivers Trust, we are now working together to put a natural-based solutions program of work to unlock the value that these solutions can deliver. And the vision is that this program of work will work from AMP8 onwards to deliver more nature-based solutions and partnership working, and that these will start to overtake traditional methods to become the default way of addressing catchment issues at system scale, supported by new processes, innovation, adaptive planning, and appropriate incentivization. And the aim is to deliver a suite of actions between now and AMP8 to remove some of the barriers to large-scale implementation of nature-based solutions and to really get us into a place where nature-based solutions become business as usual. And we want to do this as a roadmap. So there's a number of work streams that were identified and we're now developing with many other partners under this program of work. And we want to build, in essence, a program of work that goes into AMP8 and builds a multi-million-pound pipeline of investment opportunities that allows us to get out of this sort of pilot purgatory that we find ourselves sometimes with nature-based solutions, and that they become much more mainstream, much more business as usual, and that they drive the long-term environmental improvements we want to see at catchment scale. This is just very much a whistle-stop tour of what we're doing in United Utilities using CAST. I hope I've managed to convey the benefits of taking a systems approach to catchment management. It's a real game changer. At UU, CAST has encouraged us to think differently, to think more innovatively, and to go beyond our land, our catchment land and our assets, to look at the wider environment, incorporating partnerships and multiple capital approaches into our decision making, to consider what's best for the environment, for our customers, and for our communities. And I think as we move into PR24, we take the learnings from the last 5 years of CAST, and this will allow us to build a much better and much more resilient plan for AMP8 and beyond. Thank you.
Brilliant. Thank you, Amina. I feel like that seamlessly links us to our next poll question, and also then on to Amanda, who will be talking last. So before that, I'll just introduce our second poll question that we're asking you to have input on today, please, is how do we measure success of catchment-based solutions, particularly where it can take many years for the effects of interventions to be realised in improved water quality. So this is we've got some options to select on this one. So select as many as you feel are relevant, or all of them, as the case may be. So yeah, do have a look at that poll question, please, and respond to that. That would be brilliant. And now we will go on to Amanda's presentation.
Thank you, Rosanna. Hello, everybody. Thank you for having me here. So I'm going to kind of dive deep into some of these solutions that we're implementing here in the States as well as the UK. I'm going to breeze through this because I think we all know what the problems are. So nutrient pollution really is our greatest threat to clean water. Excess nutrients coupled with warm temperatures create algal blooms and hypoxic conditions, which can impair recreational uses, aesthetic enjoyment, reduces the quality of our drinking water, and alters the biological community. Nutrient loading into our waterways originate with stormwater runoff from a variety of sources, including farm fields, barnyards, roads, rooftops, parking lots, and as well as stream banks. Management is further compounded with urbanization, increases in impervious surface resulting in increased stormwater runoff volumes and amplified peak flows. These stormwater discharges are conveyed to receiving channels or streams with high velocities and shear stresses that cause erosion, channel incision, and overall degradation of the natural stream system. So as sources encompass multiple sectors, the solution to managing the nutrients in our catchments must also be a holistic approach, encompassing practices across all contributing sectors, including agriculture, communities, wastewater treatment plants, and natural resources. Nature-based solutions, sometimes referred to as engineering with nature, is a design approach that leverages the benefits of natural systems in conjunction with traditional engineering. This table provides some examples of nature-based solution treatment technologies which can be implemented for a variety of nutrient sources. Weaving natural features and processes into our design work increases long-term human, ecological, and infrastructure resilience to climate change and other environmental impacts. Nature-based solutions can reduce local flooding, protect sources of drinking water, stabilize our stream banks, and support local economies through the return of clean water and viable habitats. Previous webinars have discussed nature-based solutions for managing nutrient loads for multiple sectors. My focus today is going to be on how we utilize nature-based treatment technology specifically for surface water quality improvement. So my focus today is on two specific technologies, the use of constructed wetlands or integrated constructed wetlands, as well as waterway restoration, specifically stream restoration. These nature-based solutions, they're passive. They are low maintenance, not no maintenance, but low maintenance. They do need to repair every now and then. They're resilient against climate, not just climate, but hydraulic as well as chemical loads. They're aesthetically pleasing. They provide public space and recreational opportunities. They create habitat. They enhance the biodiversity, which results in natural capital benefits. And as they also provide carbon sequestration over their long lives. So jumping into the first, looking at integrated constructed wetlands. So the origin of integrated constructed wetlands is really through constructed wetlands that are surface flow or free water surface. And these go back hundreds of years, or 100 years for wastewater treatment. We use open water channels for conveyance and distribution, and shallow emergent marshes for filtration, sedimentation, and nutrient accretion. And then we also are using native soil. That's one of the critical drivers for the integrated constructed wetlands is the ability to use the native soil as a substrate for the vegetation. And this reduces the carbon footprint of that solution, as well as provides absorptive media for nutrients. And overall, the goal of the integrated constructed wetland is really to enhance the biological diversity and fit this within the landscape. There are a variety of treatment mechanisms that are utilized in an integrated constructed wetland, but predominantly it's through physical sedimentation and filtration and adsorption. So this is an example of an integrated constructed wetland that was just implemented last year. This is for Yorkshire Water. It's their Clifton sewage treatment plant. So what we've done here is we reused the primary sedimentation tank, but then we designed secondary and tertiary wetland cells to provide that additional treatment of BOD and phosphorus. So it's a long-term treatment strategy for the sanitary wastewater with specific focus on phosphorus retention. It's a completely passive operation, usually utilizing stop log structures and rockline cascades to convey water between the cells. Shallow marshes provide majority of the filtration and removal of the nutrients. And we maximize the treatment by utilizing the native clay, underlying native clay. And we also provided beneficial reuse of the topsoil for an adjacent pollinator meadow. This is the first operating techniques agreement in the UK, and it was the first nature-based solution for treatment of all flows. The second integrated constructed wetland I would like to talk about is that in addition to treating end of pipe from wastewater treatment plants for both secondary and tertiary as well as combined sewer overflows, we were also looking at utilizing the technology for nutrient neutrality. And this is for a development in Somerset, the Staple Grove development, which is a 40-hectare development with 750 dwellings. And the objective of the integrated constructed wetlands was really to provide that offset, that mitigation credit for the nutrient reduction goals requirements of this development. And looking at the two wetlands that are located right on individual waterways, separate waterways, we were able to capture just over about 4 hectares of total treatment wetland area, which resulted in a net benefit of 86.52 kilograms of phosphate removed annually. So in addition to constructed wetlands for point source treatment, as well as treating water from waterways, diverting water from the waterways, we can also look at the role of stream restoration. Stream channel erosion releases sediment into our waterways along with the nutrients associated with that sediment. And this can be upwards of 3/4 of the sediment in the streams can come from channel and bank erosion. Restoration of these systems have multiple co-benefits from reduced flooding, improved safety, and improved habitat. The practice of stream restoration seeks to reduce the loss of sediment and associated nutrients from the stream channel, but while stabilizing the stream channel to withstand new watershed conditions, those higher intensive storm events, more erosive storm events, but also the additional of ecological uplift added through natural processes that can be designed into the project. So addressing the stream erosion also improves the conditions for asset holders, such as designing for climate resiliency, reducing flooding impacts, protecting the existing infrastructure, and increasing public access to those green spaces. Stream restoration can be exceptional practices that encompass reductions of sediment and nutrient loads to local waterways for relatively low cost compared to other conventional stormwater practices. Now, the reason for the development of the role of stream restoration was really to look at alternatives that could be more cost effective. Traditional stormwater solutions or wastewater point source solutions are relatively expensive. But what we found was that stream restoration is significantly lower cost, more cost effective, and with many more benefits than the traditional conventional stormwater solutions. So the amount of sediment and nutrients that is credited to a project is really determined by what this originated in the Chesapeake Bay watershed. Total maximum daily loads that we're driving the process. It's determined using the program's assembled expert panel guidance document you see here on the right. Recommendations for the expert panel to define removal rates for individual stream restoration projects. Projects are credited using 4 primary protocols. There are default annual credits. However, not every stream is the same. Nutrient concentrations vary widely based upon the soil type, geology, vegetation, historic land use, and soil applications. So field soil has a significantly higher total phosphorus compared to forest soil. Sediment losses also varies depending on the rate of the lateral erosion, the bank heights, hydrology, hydraulics, and as you can see in the photos below, not every stream erosion project is the same. So this results in site-specific protocols. So understanding the existing nutrient concentrations in those banks, looking at how excessive erosion those banks are, looking at opportunities for floodplain connection, all these are taken into account when you're developing your credit and utilizing these protocols. So the majority of the credit does come from the prevention of massive sediment and nutrients that are annually lost from the eroding stream banks. But credit is also estimated using a predictive model which considers the stream's susceptibility to erosion, as well as the amount of hydraulic stress the channel's geometry places on its banks. Additional protocols account for reductions achieved through nutrient processing by denitrification and nutrient absorption through floodplain reconnection. Regenerative processes used on intermittent and perennial streams to slow flows and increase the floodplain interaction are also credited as a stream restoration practice. Let's see. And now there's a case study. So this was a case for Virginia Department of Transportation. and they have requirements to meet the total maximum daily load or the waste load allocation to their rivers. So we took the streams restoration as a unique approach to flood mitigation. This river was running right by a active, highly used road that in Buchanan, Virginia, and there was significant flooding that was occurring from the stream. It wasn't a safe. They were having to close down the road multiple times a year to address the flooding concerns. And so what we did was we designed about a 900-foot restoration of the main channel, as well as another 450 feet of the 3 associated tributaries. So the stream and the tributaries were relocated and constructed with improved geomorphology using natural channel design principles to improve the function of the corridor as a whole. Local in-stream habitat was improved for fish and microinvertebrates by utilizing harvested wood from the project in both the riffles and pools. Tow wood, log riffles, rock vein structures were utilized to deflect erosive velocities and provide cover for aquatic species. The floodplain and channels were designed and graded to improve conveyance in large storm events and reduce flooding. Following stabilization, the entire limits of the disturbance were planted with native vegetation to improve the long-term stability and provide habitat typically associated with the forest community in the region. The project received approximately 43 kilograms of total phosphorus credit, 47 in total nitrogen, and 28,000 kilograms in suspended solids. And this was actually about twice of what was initially predicted using the initial tools and default tools. So actually implementing it and studying it, we were able to get more credit than we originally planned. So Stantec is currently monitoring the site for 5 years to meet the permit requirements and perform maintenance of any invasive species that maybe try to colonize the area. So to conclude, these practices not only improve water quality, but also bring a suite of additional benefits to the community. As communities are challenged to build with resilience and replace aging infrastructure, nature-based solutions will continue to be a leading options with multifaceted solutions. And I will end it.
Perfect. Thank you, Amanda. Really interesting. Thank you. And lots of examples there I don't know much on, so that was really nice to see and hear about. Okay, so we will move on to our Q&A section, and we will start, I think, by having a look at one of the poll questions. So we asked the audience to respond to, with the changes to agricultural regulation in the UK, should water companies and other stakeholders be given more tools, opportunities and funding to help incentivise equitable, fair share behaviour of landowners? We've had quite a clear positive response to this, with 92% responding yes and 8% responding no. I'd quite like to get the thoughts of our speakers on this. And Amina, I think this is possibly closest to your area of work in many ways, and particularly to what you presented on today. So could I get any input on this from you to start, Amina, and your thoughts on it? And you probably want to take a screenshot of it and take it to some of your meetings, I would have thought. But your initial thoughts on this would be great, Amina. We can start with that.
Thanks, Rosanna. Yes, I think I completely agree. Yes, the water companies need to absolutely be more involved in that. I think the water industry have got an opportunity to be a catalyst for some of these things, and working with organisations, particularly like CABA and Rivers Trust, to convene a lot of the other sectors to support the transition from particularly for the agricultural sector into more market-led approaches, which is a requirement under ELMS and other things and other changes in farming regulation. So we're much bigger, we're more well-structured as an industry. We rely on the resilience of ecosystems, and others obviously have a big input into that. So I would say, yes, we've got an opportunity here to really take the lead and bring others with us. But again, it comes back to that systems approach. It can't be done alone. So we need to work in much more structured partnerships with the likes of CABA, Rivers Trust and others that really operate at catchment scale, have got closer relationships with farmers. And I think it's more than just the opportunity to offer more enforcement and more structured regulation. That's the stick that absolutely needs to be there, and the Environment Agency will have to do a lot more of that. But on the other side of things is also offering the carrot creating revenue streams that allow farmers to have more sustainable business, like we've done in the Petteril with Nestle, or we've done in the Wyre, which is much more coastal area, with natural food management. So it's about really joining things up and really thinking of the system as a whole. And not just offering, obviously, the stick with regulation, but providing these sort of carrot-like opportunities.
Okay, perfect. Thank you. Thanks, Amina. I'm quite conscious of time, so I'm going to move forward just because I want to make sure that we cover questions that we've had through too. So I'll just park the other poll question for the moment and we can get onto that later on. Amanda, one for you. Emily Downs asks, what happens to the phosphorus that gets retained in the sediment of the wetland? Will the sediment need to be occasionally dredged to avoid it getting too overloaded, or to avoid a possible P influx into the water from an extreme weather event? Or does the clay transform the phosphorus into a form that isn't bioavailable / isn't as harmful? Great question.
Great
Amanda.
question, Emily. Yes. So for the systems that are receiving the higher phosphorus loads, such as from the wastewater treatment plants that are the wetlands that are providing treatment for secondary, tertiary combined sewer, yes, those systems are definitely maintained. In fact, that's one of the purposes of those open water channels, to provide opportunities. They're deeper than the marshes, and they allow those sediments to settle out. Those need to be maintained, especially from the earliest cells, the initial cells. That are providing the bulk of that removal, since it is physical. So maintenance on those once every 5 years or so to remove those sediments. It's relatively easy. It just, what we use in the States here are back trucks that go in and just suck out that sediment, and that removes it from the solution. Now, within the vegetation, the phosphorus is retained a little bit differently. It's not just through those physical sedimentations. Actually, once they settle, it's buried within the substrate and becomes part of the substrate. And that's the long-term sustainable removal of phosphorus, is through accretion and burial within the system. Those we do not modify. You don't go in and dig up those wetlands. You don't want to disturb that sediment. So it's really creating avenues for easy maintenance in those open water channels and allowing the shallow marshes to grow and mature over time.
Perfect. Thanks, Amanda. Great response. Question we've had through, which I think links to a few, but I think was added during your presentation, Amanda, is nature-based solutions versus end-of-pipe solutions. This is from Rashmi Crouch. Cost comparison in pounds. Have we got a tool and time to collaborate within the catchment and quantify nature-based solutions to reach the best value solution and value by November? What is the confidence in proposing delivering a scheme via nature-based solutions in WINEP, given our dynamic climate change scenario? And that does link to one of our questions above as well. So Amanda, if we can start with you, but I think we'll definitely need input from a few people on the panel to that.
Yes, so I mean, costs vary widely for these systems. They're very site specific. You can see there's a number of projects that have been implemented by the River Trust that are much more cost effective. They're built right into these low-lying areas. A lot of the systems that we're building for the for the asset managers are within higher elevations, require more work, more modifications to infrastructure. So those are a higher cost, but they still, as we were showing with the stream restoration projects, they're still significantly less than infrastructure, more conventional infrastructure techniques. These still are order of magnitude lower than those conventional approaches. I think that was one with the first estimate for those costs. They are cost effective, but we do have to take those into consideration based upon each site condition. And I think there was also, what was the second part of that question?
Timescale, Amanda. So the need
implementing,
yeah,
implementing fast. Yeah. So we have since I think I started working on some of these UK projects about a year and a half ago. Since we started on that one, we've already had about a dozen that we're evaluating for different clients across the UK, trying to find these solutions to implementing and reducing our nutrient loads from those sources. They're all in the works, they're all driving, but yeah, I think this is a multi-year project, multi-year approach that can be modified and improved over time. But I think it's all hands on deck at this point.
Charlotte, I think we're all in the same boat and understanding what Amanda's saying there. do you want to add to that, Charlotte, from a nature-based solutions and or catchment-based solutions and end of pipe comparison and tight time frames and the monetary element too?
Yeah, yeah, time is obviously against us in a lot of this, and I think in terms of costs, it's not just about the implementation of the wetlands or whatever. It's also about the monitoring. So it's making sure that all those sort of regulatory and all those other things about the measurement, and that's where the time thing comes. It's not just the time to implement; it's the time to look at how the solution is being sort of working and making sure that we gather that data. That also is a cost associated in time that we need to take that into account. But yeah, there's a lot of time it's big at the moment to try and get all these things in, and that's where it's asking the right questions at the right time, you know, making sure that we think about these things as early as we possibly can is really key.
Thanks, Charlotte. Which links directly and almost overlaps with a question that was directed to you, Amina, from Helena, which says, how does this approach integrate with the tight deadlines for the reformed WINEP, which is exactly what Rashmi was also saying. Water companies co-creating MPS in partnership by end of November is going to be a challenge. So I don't know if you want to add to that, Amina, along the same lines.
Yeah, and Helena knows we're all facing this in the industry, but I think this is where we have to accept. We've all wanted the WINEP to be sort of transformational and, you know, the dawning of a new era into unpaid. I think we have to accept that it's not going to be the case. It's a transitional period into sort of precisely what we're trying to do with the nature-based solutions program of work, getting us into that place in AMP 9 where it starts to become more business as usual. I think it's about maximizing the opportunities to go out there into your catchments, really, again, thinking about catchments, strategic catchments, where we know a lot of the drives are going to come via the WINEP. Looking to those opportunities to collaborate. Don't try to find these opportunities alone. NGOs, CABA hosts have got loads to say in this. Really is about going out there and fine-tuning some of those opportunities. You're not going to get all of them for this cycle of the WINEP, but hopefully it will be a transitional period to prepare for the next cycle of the WINEP. And really think about the no regret adaptive planning opportunities, i.e. the long-term ones that you can continue to add to and grow, similar to what we've done in the Petteril, similar to what we're doing in the Manchester Ship Canal, is continue to grow because more drivers will keep coming, but really starting with that no regrets decisions. And, you know, in terms of costing solutions up, and the optioneering is just horrendous, as we all know, but it's really looking for those smaller and perhaps limited opportunities you can deliver the most environmental gain, and then grow with those as well. I mean, we're not going to see a lot of those with the horrendous timescales, which you've already mentioned, into AMP8, but it is the opportunity to grow into that. And I would urge you to go out to your catchments and talk to your catchment partners. Do that in a strategic way as well, really looking at the regional planning, which is something that through the Rivers Trust we're working with the likes of Northumbrian Water and others, and really think about the capacity and the capability at local scale as well. That's going to play a key role when it comes to implementing some of the more co-funding and nature-based solutions type of approach.
Perfect. Thanks, Amina. Just to mention, so the other poll that we asked, how do we measure success of catchment-based solutions, particularly where it can take many years for the effects of interventions to be realised in improved water quality? And I'm quite happy to see that it's quite a mixed bag on what people are saying that they're doing and what people are saying should be used to measure that success. And so monitoring water quality 21%, monitoring other 14%. It's a real everything contributing to that, which I think feeds in perfectly with the fact that it is a system approach, not just from a collaboration perspective, but from a seeing the response of the work being done. So that's really good to see. So Megan Jones is quite a general one. At present, my day job is far removed from catchment scale solutions, and I think we can do more. Any ideas or tips from the panel on how to design consultancies, individuals in design consultancies can help piece the puzzle pieces together? Amina, let's you to go first.
I think it's probably more appropriate for Stantec, obviously, in terms of consultants. If I would say is trying to start to build those relationships with partners in your catchments and in your regions. it starts with that in terms of understanding they've got an awful lot of intel, and obviously a lot of them do their own planning activities. So starting with that place-based relationship building and aligning planning and aligning interests with them. I mean, talk about the Rivers Trust and having myself seconded into the Rivers Trust. We've had hundreds of secondments to United Utilities between, you know, UU and the Rivers Trust and other CABA partners. It's years and years in the making of building these relationships. So I think it's building those relationships and then building the network of knowledge and intel around some of these things.
Perfect. Thank you. Charlotte, do you want to add to that? Where things are going?
Yeah, and I think relationships are absolutely key, and that's at all levels. You know, it's understanding the need, what you're there for, understanding the drivers for the catchment, because each catchment will have its own. It's not a one size fits all. But it's looking at what each system that it's being considered and understanding what's the driver, what's the needs, what partnerships and stakeholders, and what's the community need. So you're not doing these things in isolation. Is really key. But yeah, trying to sort of understand what collaboration is required, do the we part, not the I part. That's really important.
I like that. And Amanda, last but definitely not least, anything to
Concur
add to
with both Amina and Charlotte. One of the things, the challenges that we face when we're trying to design and implement these solutions is availability of land to do the work. So both the regulatory process, because we want to build in the floodplain, but also getting access to land that is, you know, adjacent to some of these nutrient sources, and really being able to build those within the landscape, make a holistic approach, and having you know, a successful project.
Perfect. Thank you, guys. So that just leaves me, before the audience leave us, we do just have one final question in the poll area, just some feedback from our webinar today. So if you can respond to that before you leave, that would be much appreciated. And Sarah will add that to the chat too for those who aren't able to access the poll feature, which just leaves me to thank our brilliant 3 speakers. So Charlotte, Amina and Amanda, thank you so much for talking and contributing and all your input for our webinar today. A special thanks also to SciWem for partnering with us for this webinar. And many thanks to everyone who's attended, joined and enjoyed hopefully today's webinar. And yeah, we hope you found it useful. You will receive an email shortly with a link to the recording. So if you missed any parts, please do listen through to the recording. There'll be more sessions from us in our Beyond the Asset series in the future. So please, if there's, please click on the link that will be added to the chat, I believe, to be able to be informed of those going forward. And if you've got any questions and the questions that we haven't got through, we will circulate those with our speakers and try and get a response back to you. So please, and if you had any you didn't ask, please send them on to Sarah. She's put her email on the slide showing there. So many thanks. Hope to see you next time, and goodbye to all.